국제 도시녹화 현황 및 식물의 공기정화 효과에 대하여 호주 유니버시티 오브 테크놀로지 시드니의 프레이저 토피 교수님의 주제 발표가 있겠습니다. 프레이저 토피 교수님은 유니버시티 오브 테크놀로지 시드니 진화 및 실험 설계 파트 수석 강사이시며 더 UTS 플랜트 앤드 엔바이러먼털 퀄리티 리서치 그룹의 책임자, UTS 생명과학대학원 명예위원회 위원장을 맡고 계십니다.
Hello, I'm Dr. Fraser Torpy. I'm the Director of the Plants and Environmental Quality Research Group from the University of Technology, Sydney. And once again, I'd like to thank you for inviting me to speak at your conference. It's a shame that this year we couldn't do this in person, but hopefully sometime in the future we'll be able to visit your lovely country again. Today I'm going to speak to you about the current status of urban greening, in particular how it affects air quality in cities. Firstly, air pollution is a really major international concern, and it has been for some time, and it's not getting any better. Air quality is clearly really important for our health. A lot of focus internationally goes on water and food quality, but those aspects are no more important than the quality of the air that we breathe. This is particularly the case in cities, where the nature of the activities we perform in cities, including the building materials we use, the transport we use, all leads to air quality in cities being highly polluted. This is particularly the case indoors. It's often thought that indoor air quality is better than outdoors, but this is usually not the case. The air indoors both experiences material drawn in from outside, but also indoor generated pollutants. These come from activities like cooking, cleaning, cigarette smoking, but also are emitted from many of the synthetic materials that we use in the modern world. In particular, volatile organic compounds are produced in large quantities. These are usually carcinogenic materials that are released from all synthetics. So as a result, the air pollution global disease burden has been stable for around 25 years now at about 3.2% of all-cause mortalities. This is not that much lower than COVID-19. It's a significant cause of mortality worldwide. And in fact, the disease burden from air pollution is increasing in some parts of the world, such as Southeast Asia, Africa and the Eastern Mediterranean, Lebanon, Israel, Syria, places like that. The World Health Organization recognises these problems and names air pollution as a major environmental health risk and has done for some years now. COVID-19 is well known to have caused improvements in global air pollution, mainly because of lower transport. There have been less people using vehicles, and that's led to an improvement in air pollution. The problem is that as a result of COVID-19, people around the world have spent longer periods indoors where air pollution is worse than outdoors, not better. So the net result of COVID-19 has been increased exposure to air pollution, not lower. Recently, it's been shown that exposure to air pollution increases the likelihood of a COVID patient getting very sick. So there's an interaction between air pollution and COVID-19. And there's some very recent evidence that shows that exposure to PM, particulate matter, may actually increase the susceptibility of someone to infection with COVID-19. So air pollution and COVID-19 do react together and they interact, leading to more people getting sick. Worryingly, the Environmental Protection Authority in the United States and the government of the Republic of South Africa are relaxing their emission standards to keep their industries running during COVID-19 lockdowns. This will lead to higher levels of air pollution and greater problems from COVID-19. It's not a good situation. So we need ways of dealing with these air pollution pollutants. It's been known for a long time now that plants can improve air pollution. Back in the 1980s, NASA did a series of studies under Bill Wolverton to use plants to generate oxygen in model spacecraft. As a side product of oxygen production, it was observed that air pollution levels in these structures were much lower than expected. So subsequently, a number of researchers around the world, including our group, started studying the effects of plants on air pollution, not thinking about spacecraft, but in terms of modern buildings, which are usually highly sealed. That last 35 years of research that we've done around the world has shown that more or less any potted plant can remove any VOC. Plants remove volatile organic compounds. Any plant, any volatile organic. The effects are really strong. The main way in which plants remove volatile organics is through the bacteria that live in the substrate. The bacteria use the volatile organics that make us sick as carbon sources and use them to grow. The plants do play a role. It's not as major as the microorganisms, but they're an important part of the system. For example, there's evidence that the plants can actually absorb pollutants and translocate them to their root systems where these bacteria reside. And of course, plants being photosynthetic organisms can reduce carbon dioxide if they're given enough light. And carbon dioxide is a particularly big problem in modern buildings because air conditioning systems are used primarily to remove carbon dioxide from the building, and this takes a lot of energy. So plants could be used to replace that process to save some of that energy. Plants remove pollutants both indoors and also outdoors. And once again, this is well known around the world. As you can see from the slide, a lot of governments around the world are increasing the size of their urban forests in an attempt to manage the growing problems around the world with air pollution. So here we have examples from Pakistan, India and Britain that are all planning increases in their urban forests to help manage air pollution. As a summary of the research on outdoor plants removing air pollution, the net effects of green spaces are well known now to produce significant reductions in particulate matter. Forests remove particulates that are produced from vehicles and industry. Similarly, plants are known to remove carbon monoxide, sulfur oxides, nitrogen oxides, ozone, and volatile organics. So all of the major groups of pollutants are removed effectively by plants. Plants, of course, can also sequester carbon dioxide and contribute to the carbon economy of cities. And this is particularly the case for big trees that keep the carbon in the wood for long periods. So the results of all this are health benefits in populations of people who live near these urban forests. Urban forests make people healthier. And of course, urban forests do a lot more than just remove air pollution. They're well known to reduce noise. They manage stormwater well, and they can remove pollutants from stormwater to save them flowing into rivers. They have physical, mental, emotional, psychological benefits on people. They make people happier and more productive. They increase biodiversity. A lot of places in the world are suffering losses in biodiversity, and urban forest is a refuge for many species, birds, animals, insects. Property values are known to increase with plants. If your property is near plants or has plants on it, it's worth more money to people. And even crime rates are reduced when there are plants in a local area. So there's many benefits to plants. However, the removal of pollutants by plants has limitations. In particular, the specific pollutant removal rate per unit area of vegetation, whether it be potted plants indoors or trees outdoors, is limited. What that means is you need a lot of plants to remove a significant quantity of pollution. The removal of particulate matter by vegetation is subject to resuspension. So what happens is the particulate matter is adsorbed to plant surfaces, and if a wind or rain comes along, that particulate matter can be resuspended. So particulate matter removal by passive vegetation is a temporary process in a lot of cases. And finally, the pollutant removal rate is limited by diffusion for all pollutants. What that means is, for a pollutant to be removed by a plant, the pollutant has to get to the substrate where the microorganisms are. There's no active method of that occurring, it's just simply through diffusion, and that's slow. Okay? So a couple of years ago, a couple of American authors, Cummins and Waring, summarised the limitations of passive plant systems for removing pollutants. They reviewed about 200 plant VOC removal studies, and what they did was they converted VOC removal by plants to the clean air delivery rate. This is the metric used by engineers for determining how effective filtration systems are. And that's a good way of measuring how effective any air pollutant removal system is. So what they found was that the results of the studies showed that the removal rate of VOCs by plants was very variable. However, the median was about 23 litres per hour per plant, which is fairly low. They then concluded that between 10 and 1,000 plants were needed for 1 air change per hour in a normal common-sized office. 1 air change per hour is the normal air refreshment rate used by modern building ventilation systems. So the conclusion that Cummins and Waring made was that too many plants are needed to have an effect on pollutant removal. And this is probably reasonable. Certainly, the way modern buildings are planted out, with 1 or 2 plants per room, is not going to have a major effect on pollutant removal. There aren't enough plants present. Similarly, in outdoor areas that have trees in them usually have an occasional tree here and there. That's not going to be enough to have a major effect. Plants can remove air pollution, but you need a lot of them. So a lot of the research in recent years has focused on ways of mitigating this and getting more plants in an area or making the plants more effective. One way of doing this, of course, is with green walls. Green walls allow a lot more plants to fit in a small area. So you can get that 10 to 1,000 plants in a normal sized room with a green wall. Secondly, with green walls, the substrate where the microorganisms are is better exposed to the atmosphere. So the pollutants can get in through the front and the back of a green wall, leading to much faster pollutant removal rates, and that's been shown in the literature. And finally, of course, green walls fit well in modern cities because they can fit into any space. Even a small space can have a green wall. So we can try and get the plants in the cities where they're most needed. So since we first started working on green walls around the world, we've tried to develop systems to make green walls more effective at pollutant removal. And it can be improved. So some things that have been tried include improving the lighting. Plants require light to survive. So if the lighting is really effective and all the plants are lit, they'll perform better and remove pollutants more effectively. Secondly, we've attempted to choose plants that are more effective at removing pollutants, and this works. Certain plant species remove pollutants more effectively than others. So choosing the plants that fit an environment is a good way of improving their pollutant removal performance. We've attempted to modify the substrates to improve the bacterial communities within them, and this also leads to good results with pollutant removal. Hydroculture has been used to improve the performance of the system to some degree, particularly for carbon dioxide. And finally, some groups around the world have tried genetically modifying plants to improve their pollutant removal performance. And this has worked. You can improve the pollution removal performance of a plant, but genetic modification is expensive and there are problems with the release of GMOs into the environment. So I don't know where that research is going to progress. Perhaps the biggest improvement to air pollution management has been through the use of active filtration methods. What this means is adding fans to a green wall system to actively move polluted air to the substrate bacteria. If you increase the rate at which the pollutants get to the part of the system that removes them, the effectiveness is dramatically improved. So on the slide, we have a system from Naturevention in Finland, where air is drawn in through the plants and the substrate into a chamber and back to the room. And on the left, we have the system we've been working with, Junglefy from Australia, where the air is drawn through a flexible ducting that can be anywhere, and similarly through the plants and back to the room. It doesn't matter what direction the air flows in, these systems are very effective. So here's an example of when we've tried these systems. What we did here was to generate smoke from diesel fuel in a chamber. You can see the top line on the graph. The diesel smoke gradually settles out of the chamber. But when you use an active green wall, it's removed very quickly. So green walls with fans in them are really effective for removing diesel smoke. Of course, we've also tried these systems out, us and other groups around the world, for different types of pollutants. You can see the VOCs on the left. What this graph shows you is the single pass removal efficiency. This is where you put the pollutant through the green wall just once and you work out what proportion of that pollutant's been removed. You can see we've got reduction rates ranging from 20% for benzene up to 95% for ethanol. These are good rates. They're very effective. Remembering this is only a single pass through the filter. If air recirculates in a room, you'll get much higher rates again. You can also see for nitrogen dioxide, very effective removal rates. This was nitrogen dioxide tested in a chamber. The top line is the empty chamber. The bottom line with active green walls in them, and you can see the nitrogen dioxides removed very effectively. This is quite important because some places in the world have major problems with nitrogen dioxide. For example, the Paris subway has got a very major NO2 problem. This system would be very effective at managing that pollution. And also ozone's removed very effectively as well. These rates are all significantly higher than potted plants. So moving on then, once the performance of the systems has been demonstrated, we need to test them in buildings. And that's the current state of the research that we're doing and several other groups around the world are doing as well, is trying to test these systems in real buildings. The first trial here was done in a residential house in Sydney, Australia, and pollutants were generated, smoke, inside a room. There's a picture on the left there of the system that was tested, just a small system in an average size 34 cubic metre room. On the right, the graph shows a range of treatments. We compared the system to potted plants, a procedural control that was a green wall with no plants or substrate in it, the empty room, a green wall with no fans, and a green wall with fans. And you can see from the graph that the green wall with plants was the most effective by a significant margin, although the green wall without fans in it was also quite effective. And all treatments were more effective than potted plants because there's just more plant in a green wall. We did that test again in Beijing, China. We're invited to go to test the system in a classroom in Beijing. You can see on the left there, the system was 9 metres squared. It was quite large. The school where we tested this system had an excellent air conditioning system with excellent particulate matter filters in it. So any improvement that we could make would be difficult. The system was already excellent. Nonetheless, you can see on the graph on the right, the blue line represents the air treated by the air conditioning system. When we put in the green wall and turn it on, you can see this is particulate matter. It decreases dramatically. So once again, the green wall was much more effective than this very expensive air conditioning system. And of course, the green wall is much cheaper than the air conditioning system. The effects seen by the green walls indoors are very high. So it then makes sense that if we made large green walls outdoors, they could potentially have a big effect on city air quality on the streets. We were fortunate enough to be able to do a trial of a green wall on a freeway in Sydney several years ago. So the roads industry government company in Australia funded this project, and we installed 5 small trial green walls on roads in Sydney and measured how well they removed the pollution generated directly from the traffic. The results here, this is clean air delivery rate per square metre of green wall. Once again, you can see nitrogen dioxide was really effectively removed. These systems are excellent for the removal of NO2. And once again, certain cities in the world have problems with NO2. Ozone was removed, but less effectively. Nonetheless, there are no other systems that can remove ozone. This system is unique in its ability to remove ozone, which is a dangerous air pollutant. And finally, we tested PM2.5, fine particulate matter. You can see that the results were not as good as nitrogen dioxide. We were surprised that the system didn't filter PM2.5 better, but the particulate matter generated by road traffic is very fine. It's very difficult to filter. So these results that we got are quite good. Certainly better than any other system. There are no systems around the world to filter the pollutants from the sides of roads. And this is a simple way of doing that. In Australia, we have major problems with bushfires. The air quality in Australia is generally very good, except when we get bushfires. And in 2019, 2020, we had the biggest bushfires that we've ever had in the country. Millions of hectares of bush burnt, leading to very high air pollution levels. In fact, for 2 months, Sydney, Australia was the most polluted city in the world. We had levels of 15 to 1800 micrograms a cubic metre of PM2.5. It was very bad air quality. A lot of people got sick because of the air quality, and several hundred people died because of poor air quality. So not such a problem in Korea, but in Australia a big problem. And fortunately, we had the ability to test the capacity of the green walls to remove some of this air pollution. And you can see from the figure, the black lines represent unfiltered air, and the grey lines represent the air that was filtered by the green wall. And you can see once again, nitrogen dioxide produced from the fire, excellent results. Ozone, much higher levels were produced from the fire than are from traffic. So we got really high performance removal of ozone. PM2.5, once again, good results, but not as good as we'd hoped. The particulates produced by fires are also very fine and hard to filter. But certainly, the green wall demonstrated the ability to remove this smoke very effectively. So, moving on, there are currently around the world a number of infrastructure scale systems that have either been built or are being planned. Just in Australia, we have the Brisbane Airport link on the side of the freeway, which is being built currently. And on the right, we have a car park in Sydney, which has been built and has been running. And that system has fans in all of the green walls. It's meant to be a car park that improves air quality, not makes it worse. We haven't assessed the air pollutant removal by the car park yet, But as an estimate, the planted area is 240 square metres, and it filters 243,000 cubic metres of air a day through those filters. So it has the potential to remove very large quantities of air pollution. Additionally, it fixes 23 tonnes of carbon dioxide a year, which is equivalent to 0.33 hectares of tree canopy. The forest with that much canopy is very large. So the car park has equivalent effects to a significant forest, but it's also a car park. So what this system does, it takes a forest, moves it into the city, and gives it a function for parking cars. So this is what we see as being the future of urban greening, is putting forests in cities that perform more than one function. Some years ago, we worked with a Finnish company called Naturevention, testing their Naval 1 green wall system. This system has fans at the top that draw in air from a room, and they pass it through the substrate and the foliage and back to the plant, back to the room. These systems have been very popular. There are thousands of these systems in offices and houses throughout Europe in particular, Naturevention being a Finnish company from Finland. But we believe that the main benefit of systems like this isn't in people's houses, it's in places where air pollution is a major problem, such as in subway stations. And happily, CoRail agrees with us, and they have installed quite a few of these Naturevention green wall systems in the subway stations in Korea, such as this one in Cheongdam, which is very good news for us to see the science that we've worked on for several decades being actually recognised and used. And of course, Korea is the country that does it, being a very advanced country. NAVA have made quite an impact in Korea. This system was recently exhibited at the DDP Design Fair, which is the largest professional business launching fair in Korea. It was great to see this being released, the system that we worked on. The exhibition was very interesting. What they did was they put the green wall systems out, they filtered the air, and they passed it back to these plastic chambers where people could go in and have a forest air shower, just breathing the air straight out of the green walls. And this is an excellent idea because people can actually experience how clean that air is. And when people feel how clean the air is once it's been filtered, they can't help but want more plants. More plants is the answer. Very well then. So where are we going in the future? We have not done enough research around the world on these systems yet. We don't fully understand how pollutants are removed by green walls, particularly volatile organic compounds. We know it's the bacteria, but we don't know which bacteria, and we don't know the systems they use to remove the pollutants. These systems are becoming popular, and they're going to be put in more subway stations and freeways. We need to know how long they'll last before they stop working. How much pollution can they absorb? And finally, we need larger scale field trials. We've done classrooms, we've done trial systems on roads. We need whole buildings set up with just green walls in them to see how those buildings perform. So we need to increase the scale of what the research we're doing. Once again, thank you for having me speak at your conference again. These are pictures from last time we came. We had a great time. We were very impressed with this organisation that you have. It was extremely impressive. And we hope that one day, soon, we can visit again and work together more to try and get more plants in cities to improve the air quality. Thank you again for having me, and I hope to see you soon. Bye-bye.